why the U.S. Needs an insurance policy on supply chains. What is the vulnerability or the dependency here? And then what does that insurance policy, in your view, look like in an ideal world? Hello, everyone. I am Kharis Templeman. I am a program manager of the project on Taiwan in the Indo-Pacific region here at the Hoover Institution. And it's my great privilege today to be able to have a conversation with my friend and colleague, Chris Ford, who is a visiting fellow at the Hoover Institution. He is also a visiting professor at Missouri State's Graduate Department of Defense and Strategic Studies. And importantly for our conversation today, he's also the author of a chapter on the semiconductor supply chain and U.S. security vulnerabilities in that supply chain. And so today we're going to have a conversation about a new report that is coming out very shortly, produced by the Hoover Institution's Working Group on Semiconductors. That report is entitled Silicon Triangle: The United States, Taiwan, China, and Global Semiconductor Security. And Chris is a co-author of one of the chapters. And Chris, I wanted to highlight the title of your chapter first. It's an insurance policy for dependence of U.S. supply chains. First off, I wanted to ask you if you could tell us why the U.S. Needs an insurance policy on supply chains. What is the vulnerability or the dependency here? And then what does that insurance policy, in your view, look like in an ideal world?
Thanks, Kharis. It's great to be part of this conversation. It's been a huge pleasure and such an honor to be part of this, the Hoover Task Force that's put this together. It's been a team effort, of course, and I'm only one piece of this, but it's been super interesting, and I have to, it bears mentioning that this is a critically important topic for our country and for the future of all kinds of things. So it's a great chance to talk about it. When we talk about an insurance policy in this chapter, I mean, the focus is it's the point is that it isn't a miracle cure to our challenges of semiconductor competitive strategy and the innovation ecosystem of tomorrow, but it's incredibly important nonetheless, right? I mean, you wear seatbelts and you have insurance policies in the car, not because you think that that's going to miraculously prevent there being any problems if there happens to be an accident, but you sure want to have something like that if there is an accident. It makes it, you're in a far better position and far better postured for it. And what we have tried to do with this chapter of the report is think a little bit about what we can do sort of analogous to an insurance policy, or perhaps wearing seatbelts, that won't necessarily prevent problems with the supply chain, but that will mitigate to some degree the worst of their effects. This is a risk mitigation contingency kind of thing. Lots of disruptions are imaginable in the supply chain. We've seen some of this over the past few years. And the thinking in the report is, what is it that we can do today, or this chapter, what can we do today that will help us be less badly prepared for challenges in the future? There are other portions of the report that deal with what I would describe as sort of the right long-term answer. How do we actually make this all work over time? The chapter I contributed to is more focused on what do we do in the short term before those particular answers bear fruit, and can we make ourselves less vulnerable in that short term?
Right. So one of the things that we've done in the short term, if we're thinking on a span of decades here, the CHIPS and Science Act, was passed fairly recently. Is that a step in the right direction in your view? And what else might need to come after that?
Well, I think it's definitely a step in the right direction. There are some really hopeful signs. I mean, we've not been in a great place in terms of the trajectory of the semiconductor sector in the United States, and frankly, in much, but not all of the Western democratic world for the last generation or so. It's been going in directions that sort of make future supply chain questions more rather than less problematic. But there's some good signs, right? We've had a number of announcements.
With President Biden flying in on Tuesday to promote a second TSMC microchip plant coming to the Valley.
Very significant decisions by major players in this piece of the private sector to build more chip fab facilities in the United States, a variety of announcements actually the past few years. I was in government when they made, when TSMC announced the Arizona fab. That was a huge point that we were very, very proud of encouraging. But so partly this is a movement by the private sector on its own terms, but partly also this is something that the government has been encouraging. And the CHIPS Act is a big piece of that, frankly. I mean, it's not a complete answer to these challenges by a long shot, but I regard it as a good step forward and almost an experiment. And that's one of the things that we stress in the report. There's no guarantee this succeeds, but it's an important step that represents it's a watershed moment in terms of the U.S. system trying to engage in some pretty deliberate, focused investment to catalyze things that will hopefully make sense and help get this off to a good start. It's priming the pump, if you will. Most of the money and the effort and the logic for this will have to come from the private sector itself, operating on regular private sector capitalist economic advantage grounds. But with a little help from the federal system, our hope in the U.S. in these last couple of years has been that this can help be a bit of a catalyst that will make that terrain make the ground more fertile for private sector decisions that will in fact help us diversify supply chains and improve the resilience of our system. I mean, there's a lot of money in the CHIPS Act, at least by federal industrial policy standards, right? It's $52 billion or something like that for a range of things. This is this is not something you solve by waving your hands and tossing money at it, but it is something that money can help. And if we are thoughtful and wise about it, the hope is this will be an important catalytic step to get us to where we need to be.
If $52 billion is not chump change, it certainly will at least, in your words, kind of provide a catalyst for this transition. In an ideal world, what do you think? The U.S. is not going to return to semiconductor dominance anytime soon, but in an ideal world, in the report we use the term balancing, so creating a kind of balance between stuff that's produced in the United States and stuff that's produced offshore, maybe in the partner and ally countries of the United States. So in an ideal world, say 10 years from now, how do you see that balance evolving? What should and could it look like?
Well, I think you've said it exactly right. This is, I would say, this is a team sport. This is not a solo sport. The game here is not. Of course, we want to bring as much of this sector and much of this capabilities as possible back to the United States. We would love to be in the position that we used to be in years ago. But you're right. That is not an available world, and that's okay. We don't need it to all be here. We want it to be here, more than it has been, and we want to reverse the trends that have been going on. But the key point is that from a perspective of supply chain resilience and our own strategic vulnerability, both to accidental interruption of supply chains, right? We saw in 2021 what market forces alone sometimes can produce. Real challenges there. I mean, ask the automakers how much fun they had at that point with no chips for their cars, right? So you don't want to be in that situation, even for just the normal perturbations of the market. It's also possible, God forbid, an earthquake or a superstorm or who knows what. There are lots of natural disaster reasons why one could imagine supply chains being very challenged. And there are some not so natural disasters, right? I mean, we're talking about a sector that is in extraordinarily important ways located in Taiwan. And Taiwan, of course, is a vibrant democracy that is threatened by a powerful authoritarian neighbor that my guess is more likely to try to resolve that problem by force now or in the years ahead than it has been for a long time, right? I mean, you see, there might once have been some constituency for the idea that one country, two systems, as the Chinese Communist Party would always promise it, might have made a degree of sense at one point. This is not that time. And especially, I can't imagine that anyone in Taiwan is looking at the prospect of unification with the mainland with anything but horror these days, given the brutal suppression of civil society in Hong Kong and so forth. So that, unfortunately, means the chances of the PLA trying to solve this on its terms, the People's Liberation Army, are probably higher than they have been in a long, long time. So there are lots of reasons why the supply chains might be very deeply challenged. And so we need to be thinking, hence the need for an insurance policy, right? It's a dangerous world. And if we can make supply chains more resilient, all the better. But the key point is that it's not just about America. Right? That's why I say it's a team sport, right? I mean, the key point is that it is a supply chain ecosystem that is one that is able to survive to the greatest degree possible perturbations outside of the PRC's technological ecosystem. And that's what I think we should be trying for. We need partners, we need friends, we need collaborators in this. And there are a lot of very clever, very savvy, technologically sophisticated and well-heeled people in a bunch of different governments with whom we can be very good friends and partners in this. And that's very encouraging.
Great. So the need to find partners and allies and to attract some of the investment from companies like TSMC or UMC or other major semiconductor producers that are in Asia and elsewhere into the United States, that need is now pretty apparent to us. You have described in the chapter that you've written a fair number of obstacles to attracting this kind of investment. And so I wondered if you could elaborate a little bit on what the federal government could do or change in how it regulates and encourages business in the United States, and perhaps what state governments could do as well to make the United States a more attractive place to manufacture semiconductors.
Sure. I mean, actually, in some ways, the pile of money involved in the CHIPS Act is the one that grabs all the headlines. But in some ways, that's actually the least important, right? I mean, in the scale of things, I mean, $52 billion across an entire sector like this feels like a lot if you're writing a particular appropriations bill, or actually in this case, interestingly, as an old Senate staffer, it was an authorization bill that had appropriations in it. Go figure, right? Who knew that was the thing? But that's not a lot of money when it comes to the actual world out there, and especially extraordinarily expensive things like building cutting edge chip fabs. And if you're going to be recapitalizing or actually capitalizing this market for the mid 21st century, $52 billion spread across an entire sector is, if it's not a catalyst, you're not doing your job right, because that will not buy you an awful lot of chip fabs. So what has to be incentivized here is moving the private sector money. And what's more important than just the appropriations there are things like the tax incentives, for example. As I understand this thing, this sector, the tax efficiency of capitalization is actually in some ways a much more important motivator than just what appropriations dollars one happens to throw after a particular grant project. And we might catalyze things, but you're not going to keep them. You're not going to incentivize the follow-on funding that's necessary for these extraordinarily expensive construction projects, if you will, unless you have a more felicitous approach to tax code. And I do think there are things that we can and should do on this. Even the CHIPS Act itself has a 25% investment tax credit for capital expenses in some regards. And that may be worth as much as $24 billion on its own, depending upon private investment levels. But that's more sort of a signal of what we should be doing than a summary of what we should be doing. And these tax issues, I think, are incredibly important, because that's really how you're going to ultimately, as a matter of public policy, I mean, ultimately the markets are going to make these decisions. But from a public policy perspective, if you're going to sort of help along the way, it's the tax code that in some ways is perhaps the most useful tool that you have. We could do things like extending tax depreciation, for example, for short-lived capital assets. At the moment, I think there's a threshold for those. We could make that a longer threshold, for example. That would help improve the competitiveness of investment in this sector. You could do more to revert to full tax deductions for R&D expenses on an annual basis, for instance. So there are things you can do. They're tweaks. These are not, miraculous cures, but they're going to be important to people who are making decisions about where the real money is going to come from. And you couple that with the greater appreciation that the private sector and everyone has now for the importance of supply chain resilience and robustness in the face of these kinds of potential perturbations. I think you're starting to talk about things that could have legs.
Yeah. Okay. And at the state level, let me rephrase this question a little bit. How did TSMC end up investing in Arizona, of all places? It's a state that has a serious water scarcity. You need a lot of water to build chips. So what incentives or what kind of environment did Arizona offer that other states could not?
Well, state competition here is is actually getting remarkably intense now that the word has gone out that one can perhaps have a fab. That's a big deal, right? That's a generational investment. It's an enormous investment, not just in terms of physical capital and employment, but employment in very high skilled, high value added pieces of the economy. So there's a lot of competition here, and states are getting pretty, in many ways, commendably ruthless in how it is that they're competing with each other and how to do this. Now, there is a word, in the chapter, we do have a bit of a word of caution here. You shouldn't expect that this is going to be, even in the most successful scenario, this is going to be like spreading butter evenly over a piece of bread, right? It will not be even. The nature of the semiconductor business is that it tends to clump geographically. That's one of the reasons why we see Taiwan having the extraordinary position that it does in this global sector right now. It is important for operating costs that your equipment suppliers and the labor and the raw materials and these things sort of like have a gravitic attraction to each other, and the costs are much lower if they're able to sort of engage with each other in a fairly constrained locality. Now, what that means from a state competitive perspective is that you probably shouldn't expect that all 50 states are going to get their nice even spread as if you were writing an appropriations bill where you're trying to goose the incentives of different delegations, right? It's going to be more complicated than that. And we'll have to live with that clumpiness, but that's okay because that's the cost of doing business in this complicated area. Arizona's been very good at being very pro-business about this. And there's also a cautionary note with respect to how other states play this. We do have a bit of a call out. It's not exactly a call. It's both praise and warning to the great state of California in the chapter of the report, which, you're out in California right now. I'm here in the DC area, but California, of course, has unbelievably powerful technical chops over the years. It's the location for Silicon Valley. It's got an amazing university system, incredibly strong technological base, and it's played that to great advantage for a generation or for multiple generations now. The danger is that in this fairly ruthless competition to be the most business-friendly place to locate your next generation chip fabs, states that are higher labor cost, higher environmentally regulatory, not right to work states. There are, this is not a pitch for social policy exactly, but it is a warning that if you are perceived as being even marginally less friendly to incoming business investments on this kind of an extraordinarily sort of world historical scale, you do run the risk of falling behind. So that's not exactly a prediction that California will fail because it has enormous strengths to play upon. But it's just a warning that this is a competitive environment, and there will be those who will be happy to offer a better deal to the next TSMC, Analog, or Qualcomm, or whomever else it may be. So it's a mixed verdict, but I do think on the whole, this issue of state competition to be a friendly locale for facilities.
So I don't want to get too wonky in the details here, but I wondered if you could talk a little bit about specifically SECA in California, or the EPA, or the kinds of environmental regulations that have, as you document in the report, have provided a kind of, or created kind of a barrier for investment in certain states and industries. And there's actually some interesting variation around the country in how these are applied. So there's a chapter on Oregon, or there's a mention of Oregon in the chapter, and Oregon has a kind of streamlined permitting process for Intel plants, where the emissions regulations that come out of Intel are actually, they're kind of put under a summary global budget in a sense. And so I wonder, is there anything you learned in doing this report that really struck you as a solution that could be taken to other parts of the country or to the federal government, things we should, practices we should adopt and spread?
Well, I think the key watchword there is flexibility, as you indicated. And it is to remember that what we're actually trying to do is encourage these things, right? The game is not one of throwing up as many obstacles as possible. It's to actually be solicitous of investment in this critical area that will be of such importance to us for all kinds of reasons. Now, that's not me taking an anti-environmentalist perspective. It's just pointing out that there are complicated balances here, and we have to be very careful as we do this, right? I mean, the procedures that are already mandated under the National Environmental Policy Act, on their face, I mean, this is hard on a good day, and especially if you're talking about things that are, as the jargon goes, a major federal action. This kind of thing has, I mean, just in terms of how practice actually happens right now, I mean, these are things that can sometimes involve review processes lasting 4 or 5 years. And that doesn't seem super competitive compared to even countries like Germany. We think of the Europeans as very, very regulatory heavy, but they know how to encourage industry. And we have to be careful that we don't throw the industrial baby out with the environmental bathwater here. So these are balances that need to be carefully struck. So how it is that we approach this kind of thing under CHIPS Act funding, for example, is part of the game. How we handle state regulations is part of this as well. I mean, you talked about Oregon as an example of flexibility here. It is often the case that state regulatory hurdles are tied in some fashion to EPA reviews, or the subcomponents of the process involve the EPA bureaucracy as well. And so this is something that as the feds administer CHIPS Act funding to try to move some of these things forward, we need to be mindful of that challenge. There are issues associated in chip fab work with, this is sort of counterintuitive, greenhouse gas emissions. Well, they're making chips. What is this? This is not a giant coal plant belching fumes into the air. Well, of course, it draws, you have to have power to do this, right? So if you're purchasing power from someplace, you, at least in theory, run the risk of running afoul of environmental regulations or additional hurdles in terms of permitting procedures that have to do with where you're getting that power from. So these are things to be mindful of. There are chemicals, for example, the PFAS chemicals, for example, polyfluoral alkalides, if I'm not messing that up in some fashion. These are things that you wouldn't think have the darkest thing to do with chips, except that it takes a lot of water to run a chip fab. And these are challenges that need to be thought of. And what we would not want to see is us embarking upon a very contentious piece of U.S. industrial policy for the first time in a long time, trying to redress a real significant strategic shortfall in how it is that our country is positioned in the world in lots of really critical ways. And then inadvertently, accidentally, if you will, after the fact, to kind of screw it all up in practice, because it turns out that for some unforeseen reason, these chip fabs are subject to incidental impact from environmental regulatory steps that were taken for other reasons and that are focused primarily on other more important targets. So the urge is just be careful and think this through, guys, because you wouldn't want to sort of inadvertently, all the good that we're trying to do with this new endeavor to save or restore our semiconductor sector, it would be tragic and ironic if we ended up balancing that whole effort up by some inadvertent, collateral damage, if you will, from priorities in other areas.
Yeah. So I want to shift direction a little bit and talk about labor issues in this industry. So the other big focus in the chapter is attracting enough engineering talent for the semiconductor industry. And this is not unique to the US. Taiwan also has this challenge going forward. But in writing this chapter, where did you come down on immigration reform? What kind of practical steps might we take to create a more competitive and more vibrant workforce for a semiconductor industry?
You've touched the third rail here, talking to a former congressional staffer about immigration reform.
Yeah.
Look, we are lamentably stuck when it comes to comprehensive immigration reform in a bunch of different ways. My hope is that in this particular corner of the immigration question, where there is bipartisan support for saving this high technology sector and ideally bringing much more of it back to the United States and solving some of these, or at least risk mitigating some of these giant supply chain dependency challenges that we have. Maybe in this particular corner, there's some hope for progress. I mean, I don't know. It's a hard question. I would love to see, in a sense, a two-pronged approach. And we sort of talk about this a bit in the chapter of the report. I mean, on the one hand, the ultimate objective, of course, is that we train Americans to be valuable human capital to help make this industry possible. There are mechanical, electrical engineering, a bunch of technical specialties and so forth that would be incredibly valuable to help provide the labor force for these fabs, which, I mean, that's part of the business of attracting them to come here to the US. It's part of the business of keeping them. And it's a lot of important jobs and a lot of salaries and benefits and prosperity for the people in these positions. We want Americans to have those jobs as much as possible, and we should be training them. But that's not going to happen tomorrow morning. And, at least until we are able to make those kinds of training pipelines provide value added, we've got to find those workers someplace if we want these to be competitive sectors in our economy at all. And I think that, at least to some degree, some kind of tweaks from a legislative perspective to our immigration law. That could be green card cap adjustments. It could be H-1B visas. But the skilled workers that we do need in this sector, really terribly vitally, have to come from someplace. And unless and until we are successful in training enough Americans in this, which we are not yet, it's got to come through some degree of immigration reform. And that may be a hard thing for folks on our stuck congressional community to hear. But if we're serious about things like the semiconductor sector, we have to be thinking more in those terms than we have for a bit.
Yeah. Spoken like somebody who's made this pitch before, it sounds like. I wanted to get into one other wonky thing in your chapter, which is about data and information about the semiconductor supply chain. It turns out, as we learned in convening this working group and walking through some of the deep issues in supply chains, we actually don't have good information where a lot of the inputs into the semiconductor manufacturing process come from. So you had a really interesting suggestion, and the chapter really walks through quite nicely some of the major advantages you can get from actually just improving the information that's publicly available on the supply chain. Can you talk us through that a little bit?
I can try. I mean, I was, my last tour in government was only a small window into some of these issues. It had to do with export controls and this kind of thing. But even there, I was quite struck by the degree to which the government policymakers who make decisions about who should be able to export what and to whom, really had a hard time getting really good data. And by the way, not just data, but analytical support, right? So it's modeling. It's there's a lot that goes along with data because, of course, a pile of figures, by themselves aren't all that useful all the time. So, but there's a sort of, data and analytics. It's actually it was surprising to me how much more I wish that we had for making some very important decisions on things like export control. It's true, that it's so much more true if you look across the entire sector on how it is that we should be approaching these issues as a matter of public policy. I mean, if the government is going to be involved in doing things like the CHIPS Act and tax incentives for investment and encouraging chip fabs to come to this country, I mean, there are those who think that that the government should be in this business at all. I used to be amongst them. I'm no longer there. Things have gotten bad enough that, look, it's time to try to fix this if we can, or at least to be helpful. But you can't be helpful if you don't have the tools with which to be helpful. And some of those tools is data and analytics. And we have to do better. The last thing that we want is a government that decides it wants to involve itself in something that looks a lot like industrial policy that is a stupid government. We want it may be a necessary evil, but if you're going to do it, you've got to be smart about this. And that means getting the data upon which to make decisions. And we aren't very good at that yet. And there are some areas where energy is one of the areas we talk a little bit about in the report, just by analogy. We are nowhere near where we need to be in the semiconductor field. And we're certainly not that way either for industrial inputs in general, nor for, in fact, exports. Now, I'm a sort of a national security guy by background, and I care a lot about how do we know who does the net assessment for who's winning in this competition, right? I mean, what is China getting from U.S. technology? We don't really know that very well. Where is the U.S. sector in detail? And the private sector may know a lot of this data because that's what they do, and that's tremendous. But I do think, especially now that we are talking more and more about having government policymakers involved, at least even on the margins of this, making sure that those government policymakers are as well informed as possible is just common sense. And I understand that the private sector sometimes gets uncomfortable sharing lots of intimate data with the government, but I have to imagine that I think if I were a private sector person, I might prefer that I share with nobody, but I'd certainly rather share with a government policymaker than I would have that policymaker blindly start making decisions right, left, and center about my business, right? So I think we have a collective interest in making sure that the data and the analytical support for that data is done properly. And that's going to take some work. We're not there yet. But there is a lot of information out there. This is an era in which there is an extraordinary amount of that one can learn through data aggregation of various sorts, cooperative information from the private sector, things like export licenses, which are not quite so cooperative, but are very useful. And just, sort of generally applying analytical methods to what I've heard called the digital exhaust of the modern economy. There's a lot you can learn. And if we are not learning those things, I think at this point, it's creeping towards being some kind of malpractice. So I do think data is a huge piece of this, and we have to do better at that.
Okay, great. On a related question, one proposal to prevent a repeat of the chip shortages of the last couple of years in this country is to have a kind of national chip stockpile that's ostensibly modeled on our strategic petroleum reserve. And you discussed that at length in the chapter. Why are chips not the new oil? Basically, let's put it that way.
Well, I love the idea in theory. I think that the basic intuition that we need to be doing more to prepare ourselves for some sudden shock is quite sound, right? I mean, we saw, as I mentioned earlier, the problems that car makers encountered in 2021 are, and on some level, it's like nothing compared to what one might imagine happening in the event, for example, of a conflict over Taiwan. So something that is stockpiling-ish seems to me like an incredibly important idea. Now, doing that is really hard. Now, could you, and we talk about this in the report, as you noted, the idea, I don't know what it would mean to stockpile truly high-end chips, right? I mean, if you can buy lots of them and stick them in warehouses, then you're almost by definition not talking about the real bleeding edge sort of stuff, right? That's not available in that way. So there are some aspects of this that just don't make a lot of sense. And even stockpiling lower end chips, while there is a lot of value to it, it'd be very hard to do given the diversity and the kaleidoscope of different chipsets that actually exist for different applications. So very hard to do, but that doesn't mean that you can't do anything. And there are some analogies that I think make a lot of sense. Just to take one example, in the aerospace industry to some extent, and also in Pentagon procurement, there is a lot of precedent for doing lifetime buys, or whatever the term you want to use for this. Like the anticipation is that you will buy enough at first instance to last through whatever permutations you can foresee of you using the items in question that require those chips, so that you actually, after the initial purchase, you actually aren't dependent upon an exogenous supply chain, particularly for follow-on stuff. Now, we haven't always done that very cleverly, right? In Pentagon procurement, as we're seeing to some degree with the Ukraine war, procurement, efficient, low-cost procurement that has focused upon peacetime, attrition and utilization levels don't make a lot of sense in a crisis. So if you're going to take this seriously from a crisis risk mitigation perspective on semiconductor supply, lifetime buys for particular key applications, you'd have to be pretty serious about buying lots of fallback material. But you could do it, and that's not necessarily the legacy systems that we were most concerned about in a crisis are not the cutting edge, crazy gaming chips or whatever. They're pretty garden variety things that keep our water supplies going in our car. It's not the high end stuff. So there's I think a lot of possibility there. And we should be thinking more in terms of trying to structure acquisition of things with those kinds of things in mind. We could use tax incentives, for example, to incentivize having longer, slightly longer inventory buffers, for example. Buffering is really more the concept here than stockpiling. An analogy to the strategic petroleum reserve is intuitively appealing, but very hard to do in practice in this sector. But I think you could do more to make buffering against disruptions a much more viable strategy. And that's something that we should be more clear about. And if worse really comes to worse, we need to be thinking in the back of our heads about what a strategy would look like for chip rationing. in the event that these things were really the heck cut off. And only a certain amount is available from whatever suppliers they might be at that point. How do you think about who gets what? I mean, if you're in a war with the PRC at that time, do you prioritize replenishment munitions and replacing satellites that get swept from the sky by Chinese counterspace or whatever? I mean, you need or first responders in domestic contingencies, right? So having a rational conversation about what the prioritization deck will need to be, if God forbid it comes to that, it's probably also a conversation that somebody should be having in a quiet room someplace with representatives from industry.
Yeah. All right. Last question here before we wrap up. And this is based on an observation. You actually have a co-author for this chapter who has chosen to remain anonymous.
Indeed.
Why is that? And what? More broadly, what are the implications of that, do you think, for our own ability to do this sort of analysis?
Well, let me say, first of all, I'm incredibly grateful. And I know the co-author is probably listening to this podcast or will be. And this chapter is not, I certainly can't claim credit for all this chapter. And it was a pleasure being able to work with this person. Now, the challenge came because this is a Chinese-American author, a scholar who is really good on all these topics and knows much more about much of this than I do. And it's been such a pleasure to work with him. But he opted to withdraw his name, as I understand it, from public association with his report because he feared for his family in China, were he to be associated publicly with advocacy of things of which the Chinese Communist Party disapproves. That tells us something I would say really important. I mean, first of all, I want to make sure that your listeners understand that I didn't do this by myself and that there's this other unnamed person out there who deserves, if anything, more credit for this chapter than I deserve. That's the first point. But the second point is that it is just so disgusting and disgraceful that things would be at a place where a scholar in the United States needs to fear for the safety of his family if he says things that a foreign autocracy disapproves of. And that's sort of kind of a point here, right? And this tells us, I would say, a little bit about the stakes involved. Because this is a semiconductor industrial policy strategy kind of report, but it isn't just about semiconductors. It's not just about technology per se. It's not even just about jobs or growth or the economy. It's about more than that. And the reason, one of the many reasons why this matters so much, as I see it, is the Chinese Communist Party has this vision of the world in which it aspires to use things like supply chain domination in fields like semiconductors and generally seizing what their strategists call the commanding heights of emerging technological capabilities to acquire for China in the mid-21st century the kind of first mover advantage that the British Empire had with the first industrial revolution. Indeed, Xi Jinping talks openly about plans to essentially be that first mover for a fourth industrial revolution, because the CCP wants to get for China the kind of geopolitical advantages in the world that first industrial revolution gave to the British Empire 2 centuries ago. And if we don't remember that, we are missing, to some degree, the point of why this technology stuff matters. It's not just about clever widgets, and it's not just about jobs and growth and all those cool things, which are important. It is about geopolitics and security on the most epic scale. And that's what my co-authors, sort of fears for his family remind us of. Like, it tells us a lot about the kind of regime that wants that sort of geopolitical dominance through technology in tomorrow's world. And that's why this matters. So if I can leave your listeners with one thing, it's that this is the stakes that we're talking about here. And so semiconductors are important only as a piece of that larger narrative, but damn, that's important.
Spot on. Thanks, Chris. Very eloquently put. We will wrap up here. I want to thank our listeners out there, wherever you may be. And just to plug the report again, it's entitled Silicon Triangle, the United States, Taiwan, China, and Global Semiconductor Security. And it's a production of the Hoover Institution.
Such a pleasure talking. Thanks so much for having me on this podcast.
Thanks, Chris. I'm Kharis Templeman. Silicon Triangle is a special podcast series of matters of policy and politics.
This podcast is a production of the Hoover Institution, where we generate and promote ideas advancing freedom. For more information about our work, to hear more of our podcasts, or view our video content, please visit hoover.org.